Hey guys, thought I might as well go ahead and do another PowerPoint video. So far, I've not really gotten any feedback from the last one, so I thought I might as well just do it. This one's gonna be over actually MIG welding, so I'm sure I'll probably have this video up and a couple more made videos out in the shop. It just kind of depends. My camera kind of sucks, so it's hard to actually take videos of me welding, but I'll do my best. So gas metal and flux core arc welding. Learning objectives. We're going to contrast the difference between gas metal arc welding, between flux core probably. Considering arc characteristics, weld characteristics, and precision welding. Select the proper arc welding machine, wire feeder, shielding gas, flow rate, contact tip, nozzle size, and welding wire for the kind of weld that we need. I'll I might have a few different types of wire out there. I can show you the difference between an 045 weld and an 035 weld. Only have one kind of gas. Well, we have two kinds of gas. I have a little bit of argon, oxygen left. So I might get into spray welding. I don't know. It just kind of depends. Identify the different shielding gases used and explain how they affect the shape and penetration of the weld. Properly assemble and adjust all the equipment required to produce an acceptable weld using MIG and flux core. Make acceptable welds on all types of joints. So I'll probably go over the five joints, butt weld, T joint, corner joint, edge joint, uh, lap joint. Sorry, having a brain freeze. It's kind of early still. I might make a video for flat and horizontal. They do weld differently. Um, Gravity plays a big part when you have a weld puddle, so kind of just have to build up muscle memory on how to do it all. Gas metal arc welding processes use a solid wire, which we already covered that. So MIG is nearly always performed with direct current electrode positive, DCEP. That's a big one. So it's almost every single time you're going to MIG weld, it's going to be positive, okay? A variable waveform is possible if you have an inverter. Don't know what that means. There are very thin glass-like islands over the weld bead. That's actually from the silicone in the wire, just rising to the top, and then it hardens into like a glass-like thing. If you're doing multiple passes, you really need to try to get those off, which will I'll show that out there. Molten filler metal is transferred from the electrode to the weld pool by different methods. So short circuiting is going to be probably the most popular kind of MIG welding out there. I've only worked at a couple places where we sprayed things, and that was just very sporadic. It wasn't like an everyday thing. Globular transfer, I have never done that. Spray and then pulsed spray. I had pulsed spray when I was at Major Tool Machine down in Indy. Mainly did that on Inconel. It's a nickel chrome alloy, so it welds a lot different. That's a weird metal to weld on. Short circuit gas metal arc welding is used with relatively low welding currents. So I'd probably say anywhere from like 15 volts to 26-ish volts. Short circuit transfer is particularly useful on thin metal sections and to fill large gaps. So if you do any sheet metal MIG welding, welding, it's probably going to be MIG or TIG. But if you're and to fill large gaps, so like for example, on the bin tests or the welding certification tests we do, you'll have an 1/8 inch gap. It's kind of a large gap when it comes to welding. The combined effect of surface tension and the pinch force separates the molten metal and the electrode. Sure. Sequence of metal transfer. Metal short circuits to weld pool. It pinches it off. Then the arc rehits, and the wire nears another short circuit. So that's why it kind of sounds like a good short circuit weld sounds like frying bacon, because it does that over and over and over again real fast. So it kind of makes like a crackling noise. An ideal short circuiting transfer rate and pinch force can be obtained by properly balancing the inductance and slope. Okay. I don't know. I don't really know a whole lot behind like the technical side of welding. To me, you don't really need to know it. I don't know what that means, and I'm a pretty good welder. So, but there it is. If you know what that means, if you want to know what that means, let me know. I can try to learn a little bit more. It's never come up in my work experience. Shielding gases may also have an effect on short circuiting transfer, so that's true. Carbon dioxide or CO2 definitely gets a lot better penetration. It's a lot hotter. It's a lot more. I wouldn't really say hectic. It's just a lot rougher of a weld than like 75-25 argon CO2 mix. Inert gases must be used on all non-ferrous base metals. So like you can't use CO2 on aluminum. It has to be totally inert, like just straight argon. Advancements in technology have made modification of the short circuit transfer processes possible. Use of an inverter power source results in lower average current and less heat into the weld joint, and spatter is significantly reduced. Again, that's what it says. I don't have any background knowledge to add to that. I don't think I've ever MIG welded with an inverter power source. Those must be relatively new. Probably pretty expensive too. So most smaller companies probably won't have those. The new welders. I don't know though. I mean, globular transfer. Metal transfers across the arc as large, irregularly shaped drops. To minimize spatter, using CO2 current is increased slightly to create a buried arc. I don't think I've ever actually done globular transfer. It looks like it kind of gets a lot of pretty good penetration there. We won't cover that in this class. So spray transfer, we will spray a little bit, mainly just because the spray certification test is incredibly easy, and so that's one that everybody should be able to get in this class. I mean, it's if you can run a straight line, you'll get certified on it. Spray transfer occurs when very fine droplets of metal form at the tip of the welding wire. Spray transfer takes place only when the shielding gas contains a high percentage of argon. So again, we'll use a 98% argon, 2% oxygen mix. That just helps it get real hot. Spray's kind of cool. I thought it was kind of cool. Like it's cool seeing the wire, and then it just like looks like a spray can coming out of it. So it just like really lays down some really big welds. It's kind of cool. Pretty quick. As long as you're pretty steady, you can run a really nice looking bead with it. Welding machine's current must be set above the transition current. The spray transfer method produces deep penetration. Spray transfer is best done in flat or horizontal welding positions and on metal over an eighth inch thick. Penetration from spray transfer with metal cord wire is not as great as it is from spray transfer with solid wire. Again, metal cord is relatively new, so I don't know anything about that. I do have one spool that I need to get out to the shop and mess around a bit with, but these modules kind of take a long time to do, so I've not really had a lot of free time. Pulsed spray transfer electrical control circuits within the power source cause the current to pulse from a low current level to a high current level. So it's kind of just like ramps up, drops off, ramps up, drops off. At the high current level, spray transfer droplets leave the electrode and enter the weld pool. Oh, excuse me. Uh, okay, we won't be doing any pulsed spray transfer here. Um, MIG and flux core welding power sources provide a constant voltage. Uh, MIG and most flux cores are done doing direct current electropositive again. With inverter power sources smaller and lighter than traditional transformer rectifier machines, may provide a choice between constant current and constant voltage. Two important variables are used to set the welding parameters for MIG, voltage, and wire speed. Um, the wire feeder may be built into the power source or may be an external unit. I think we don't have any internal units here. They're all external on top. Have the wires pull outside, which I think I said that in the other video. Setting up the MIG and flux core station. Connect a separate wire feed if required. Mount the welding wire wheel onto the feed. Determine what shielding gas is required. Check that the regulator and gas flow meter are attached properly. Check hoses and fittings for leak. Connect the welding gun, and connect to the workpiece lead or the ground clamp. So, going off of my Ivy Tech kids that I've been having in here, uh, the ground clamp is the first thing that you guys should check. I was actually getting kind of a little bit peeved at some of my Ivy Tech students. It'd be like week 7 or 8, and they'd be in here and they'd be like, "Hey, Mr. Chris, the welder's not working. It won't strike an arc." And I go walk in and there's no ground clamp on the table. And it's like, guys, like it should be like the first thing you should check is the ground clamp if there's an issue, um, especially if it's not striking an arc. But yeah, anyway, we'll get into that. Hopefully, you guys come back soon. This is it's Wednesday, the week before I'm gonna let this module up. And last night in the board meeting, they were talking about meeting to get you guys back in school. So uh, hopefully that has happened soon. I really hate this online stuff. It's terrible for you guys. You guys could memorize this whole book and not know how to weld. So it's completely pointless, in my opinion. You guys really need to get in here and actually do things, which I'm excited for. So hopefully they come to a decision soon and we can get back in next week, this week, week after, whatever, into January. I'd be happy with that. You guys just really gotta get in here and do it. So, setting up the power source. Power source must be adjusted based on the following: type of base metal to be welded, base metal thickness, type and diameter of welding wire, transfer method to be used, type of shielding gas to be used. So there's a lot to just consider, to think about when you're choosing a wire and what what parameters to set your machine at. Like you won't weld if you're welding on 3/8 thick mild steel. Okay, you're not going to use the same voltage and wire speed for 035 wire and 045 wire. Okay, when you guys get in, I'll show you guys the difference. I mean, I know most of you guys don't know what 10 thousandths is, but it's pretty small. You wouldn't think that just 10 thousandths, since 035 to 045, the difference is 10 thousandths in diameter. It's actually quite a thicker wire. So it takes different settings. Welding machines microprocessor contains a set of welding values. Okay, why are we talking about microprocessors? Okay, setting up the wire feeder. Okay, 2 mated gears are located in the wired drive unit. 1 gear is driven by an electric variable speed motor. A roll is attached to each gear, and a 4-roll wire feeder. 2 rolls are driven. So, like here, you can see your drive rollers. the wires. That's what's going to pinch the wire and roll it through your gun. We'll go over these more in class. I'll probably do a whole day or two of just out in the shop going over a machine and every piece of it with all the different machines we have out there. It'll probably take a day or two just to get you guys familiar with them, and then when you guys start using them, you guys will know a little bit better. Setting up the wire feeder over time, an adjustment may be needed to the wire guides. The wire can get jammed and cause a bird's nest. That must be removed. So bird nesting is probably one of the most frustrating things you'll have to deal with when you're MIG welding. You'll be welding, and everything will be fine, and then all of a sudden the wire just won't come out of your gun. You'll hit the button, nothing happens. You go back and look, and there's a big jump on the wire on your machine or inside your drive roller assembly setup, and it's time consuming to fix. I wouldn't say time consuming. It's fairly quick, but it's just like when you're on a roll, you want to keep on a roll, So it's just kind of annoying. Select and install rolls that have the same groove diameter as the welding wire. Again, you can't use 045 rollers on 035 wire. It just won't work. And if you use 035 rollers on an 045 wire, it'll pinch it too bad. Final adjustment is to apply the proper force from the rolls to the electrode. Wire feeders often include an inch switch or jog switch used to feed wire to the gun. When the purge switch is depressed, shielding gas will flow. Again, that's to purge old gas or air out of your line, or to help you set up the flow meter. Oh, shoot. Gases and gas mixtures. Shielding gas cylinders can be ordered with a single shielding gas or a mixture. Gases can also be created in a gas mixer. I have never once seen that. I don't know why you wouldn't just buy a gas mix. Each shielding gas and mixture has a different effect on the shape of the bead and the penetration. So again, this is the same little image we saw in the last video. Argon results in high current density arc, deep penetration, and narrow bead, and almost no spatter. Is the inert gas most commonly used for welding non-ferrous metals. But yeah. Helium transferred heat through the arc better than argon. Is often used to weld thicker and non-ferrous metals. An argon-helium mix will weld a lot harder than just an argon mix. Helium does add a lot of heat. Carbon dioxide has higher thermal conductivity, requires higher voltage than argon. Is the only reactive gas used alone as a shielding gas. For MIG, carbon dioxide is used only with short circuit or globular transfer. CO2 is the most common shielding gas for flux core. Good ventilation is required when using pure CO2. About 7% to 12% of CO2 becomes dangerous CO in the arc. Carbon monoxide. The amount of carbon monoxide increases with the arc length. Okay. Again, I don't really think that'd be an issue unless you're welding over your head and it's falling on your face, or you're right next to your weld, breathing it in, which wouldn't happen. Argon helium produces a balance between deep penetration and stable arc. Argon carbon dioxide helps eliminate undercutting when carbon steels are welded with spray transfer. Argon oxygen added O2 improves weld contour, makes the weld pool more fluid, and eliminates undercutting. And I can't read what the trimix does. Enough gas must flow to create a straight laminar flow. Turbulent flow can draw in atmosphere and cause the weld to become contaminated. When too little gas flows, the weld area is not protected, and the weld can become contaminated. Set the proper flow rate using the flow meter. So too little gas can cause a problem, because you kind of have to imagine the air is like a fluid. Okay, there's a lot of air pressure. So if you don't have enough, then the air pressure is going to move your gas out of the way and cause weld defects. Too much gas is also a problem, also because it kind of creates a vortex. So it'll start spinning, and it'll just draw in atmosphere and cause an issue that will cause porosity and weld defects. The gas nozzle delivers shielding gas to the weld area in a smooth flow. Nozzles are available with different exit diameters. You can have like real skinny ones, real big ones. Um, just mainly you'll just use whatever your company has or whatever we have. The contact tip makes the electrical connection between the welding gun and the electrode. Contact tips have different inside diameters and lengths. Different lengths help obtain different transfer methods. Yeah, there's a lot that goes into the consumables of a welding gun. Resistance heating of the electrode takes place after the welding wire exits the contact tip. A large contact tip minimizes electrode extension and reduces resistance heating of the wire. Oh, excuse me. Yeah, this is probably the most I've talked in probably 4 months. Contact tips wear and must be changed regularly. Clean spatter out of the nozzles as needed to maintain good flow of shielding gas, which you'll see that when as you start welding and it starts spattering, and it'll just kind of collect on the inside of your gas nozzle. So just clean that. It's relatively easy, simple, pretty quick. Don't ever do this with your bare hands. Okay. Um, there are very few things as unpleasant as metal splinters, because they're freaking tiny and you can't see them, and you'll rub it the wrong way, and then your finger gets infected, and then it's incredibly painful. Okay, so don't ever touch your guns and stuff like this with bare hands. Again, always wear gloves when touching anything in the shop. Okay, nothing in there is soft. So the liner protects the cable from the continuous wear of the welding wire. One type of liner is hardened steel wire wound to form a tube. It looks like a really tightly sprung or wound spring. Second type of liner is Teflon, which is used for aluminum wires. We use it on aluminum wires, some stainless wires. I think we use them for Inconel wire. Uh, it's pretty much any wire you don't want contaminated by the steel. Compressed air can be blown through the coiled liner to remove very fine particles. Um, we'll probably do that about once a year. It takes a while for a liner to go bad, unless you kink it. Always point the open end of the liner towards the floor or trash can when blowing out the line. Duh. Never allow the open end to point towards yourself or another person. Yeah, because it's shooting really fine metal flakes at people. Um, we'll go over in person how to replace the liner. Preparing metal for a weld. I wonder how many slides there are. Oh, 79. Okay. To produce quality welds, the base metal must be properly prepared. Metal surfaces are cleaned mechanically or chemically. If the metal being welded is expected to remain oxidized prior to welding, select a welding wire with more deoxidizers. Joint designs are similar to those used for shielded metal arc welding, stick welding. Preparation of the weld joint. Depending on the metal's size and thickness, tack weld about every 3 to 4 inches. Tack welds can be feathered, making it easier to join the weld bead to the tack welds. Okay, actually, since we're about halfway through, I'm going to go ahead and end this video, and I'll pick it up in another video. So I got to go get me something else to drink if I'm going to keep talking. My throat's kind of dry. All right. Let's see. Alt-T. I don't actually know how to stop recording. Did I not record any of that? Oh, yeah, I did.